go to page 41 in your journal and get the definition for average rate of change and system of three linear equations. You also want to take a look at vertex form of a parabola and intercept form of a parabola. Take a look at the notes when you get a point and vertex. So when you're given a point and vertex form, these are the steps you'll follow. When you're given a point and x-intercept form, or the x-intercepts, these are the steps you will follow in blue. And then when you're given 3 points, you will use quadratic regression in your calculator. Copy these down. Now take a look at example 1 in your notes packet. We're writing an equation using a vertex and a point. So this will be like that first set of directions that I gave you in your journal. So read the problem. And now we have to figure out our vertex is given at 50, 35. So this is our H and our K. And then we want to find another X and Y. I'm going to use 0 and 15 because that's also given. So if I solve for A using this equation, I'll plug in my values and find A. Be careful with negative signs here when you're solving, and your answer for A should be 0.008. Now that I have A, H, and K, I can write my formula to be negative 0.008 times x minus 50 all squared plus 35. And the last step is to take 90 feet and plug that in for my x and solve for y. So go ahead and calculate that value. So I've circled my two answers in red. I've got my equation and the height of the net when the performer lands 90 feet. Read example 2 and look at what I've underlined for the important parts of the question. Now note that we're given the x-intercepts and another xy point. So 4 will be my P, 24 will be my Q, and then I have x and y. So for part A, we'll solve for A using the equation x minus P times x minus Q. I plugged in my x, my y, and my P and Q, and I'm solving for A, and you should get 0.1 for A. So then I can write my function that models this. We'll have f of x equals 0.1 times x minus 4 times x minus 24. To find the coldest temperature, that's going to be my vertex at the bottom here. So I know to find my x, I just do P plus Q over 2. So that's 4 plus 24 divided by 2, and that's going to be 14. So when x is 14, I have my coldest temperature. So I'm going to plug in 14 for my x. And then go ahead and calculate that. For part B, my axis of symmetry is x equals 14. So to figure out where that is on the graph, we can see the function is decreasing from 0 to 14, and then at 14 the function starts increasing. So for decreasing, we're going to say my average rate of change is f of 14 minus f of 0 over 14 minus 0. And that's going to be negative 10 minus 9.6 over 14, which will be negative 1.4. So the average rate of change is negative 1.4 degrees from 0 to 14 hours after midnight. Okay? Then if we do the increasing, we'll do from 14 all the way to 24, the final point, and we'll get this. So for part B, we can say that all the answers circled in green. For decreasing, I have negative 1.4 degrees for the hours after midnight. And then for increasing, we increase 1 degree every hour after midnight. And then we can say, to compare the two, that the temperature changes at a greater rate from midnight to 2, which is 14 hours later, than from 2 p.m. to the end here. Okay. Looking below at the next part, we notice that in this table, we can see the first differences are all different, but the second differences between the y values, when we figure out how much is between each, are the same. So if the first differences are the same, the function is said to be linear. We looked at that last chapter. If the second differences are the same, the function is quadratic. So now let's look at example 3 and figure out if this is going to be linear or quadratic. To do that, I just get the differences between each y, or h in this case, and see if they're the same. Notice the first differences are not the same, so this relationship that's being described in the problem is not going to be linear. But then if I find the differences the second time, we're going to see they should all be negative 550. So check that. From here, we can see that this will be a quadratic relationship, and tomorrow in class, we'll enter L1, L2 and do a quadratic regression in the calculator, and we'll do example 4 as well.